Good morning, everybody. Good morning for me, anyways. I come to you from the nerd cavern, and I am incredibly excited today. I don't know if you could tell the glint in my eye, the slight drool. I am so lucky and privileged that my fabulous friend Agna has put me in touch with Rob from the European Space Agency. Rob has been working. I'm going to let him do the talking about this because he's the most wonderful space nerd you could possibly want to speak to about this. We are talking 3D metal printing in space. Like, I can't believe how lucky I am to be alive to see this happen. Yesterday, I had a wonderful chat with Miguel, who talked about his pancake bot, where we're literally talking about printing pancakes. And the next day, I get to talk to Rob about 3D printing metal in space. And so I'm going to welcome to the chat Rob, and we will dive into this stuff because you are going to love this. Rob, welcome. Are you muted is my question.
Indeed.
And that's because
on special request. Good start.
I know. I said, please could you mute for the beginning? And of course, naturally, there's
of course, always.
Yeah, no online chat is officially a go until someone has muted themselves. Basically, usually it's me.
It worked. We can say that for sure. But a pleasure and an honor to be here. And thanks for the wonderful introduction.
I'm going to do some boring technical stuff first. I want to just make sure with the chat that everyone is hearing everything okay, that everyone's seeing everything and hearing everything properly. I don't want to do what I did the other day, which is unplug my microphone and talk for 3 minutes, excitedly about my day. Without finding that there was no sound. And, oh yes, look, there's actual excitement because apparently there is sound this time, so that's wonderful. Rob, would you mind just giving people, who are you, what are you working on, a little background first before I totally geek out about your fabulous printing?
Happy to do so. Hello to everyone. I'm Rob Postema. I'm working at the European Space Agency, living and born and raised in the Netherlands, in the coastal area, very nice area. Working with the European Space Agency now for about 15 years, and the most recent 10 years in the area of human and robotic exploration, which is extremely exciting. And the focus here is on, for me, is on making sure that everything we as European Space Agency have on the ISS, the International Space Station, and then it's mainly in the Columbus module, which is the European module of the International Space Station, is to keep all the instruments up and running, making sure that we can do everything we wanted to do with it. And as part of that, I've also been involved in coordinating the development of a metal 3D printer, which, as we speak, is in the space station from early this year onwards. And as we speak, we have or are still printing today.
It's just amazing. I mean, is this something I got to ask? Like, when you were like a little kid sort of staring up at the sky, were you thinking, oh my God, I can't wait to get up there and start 3D printing stuff? I mean, how do you get where you got? You know what I mean?
I must say from young onwards, I was just thrilled with the aerospace domain. Yeah. I think it's also the apple doesn't fall far from the tree. My dad was working for the European Space Agency. So as a little kid, I was already in a position to visit the laboratories here, and then it was raised with that as an idea.
I see. My father took me
something in space.
My father took me into the hospital to watch him do operations, and that just put me off everything. So
okay.
It worked for you. Yeah.
It can work both ways. But that I would end up with leading the development of a metal 3D printer, I would have never expected and anticipated at that time. It was just I've never been eager to go to go to space as crew, but to develop instrumentation for use in space, yeah, I think that was an early interest already. And I think by young, I already knew that I would be studying aerospace engineering and
Right.
work for a space company.
Now,
So
now
here we are.
the way it's organized is really cool. We were talking about this before, but you're saying you're sort of put in charge of different sort of sections of the space station. Like it's almost you have like a little room for rent, and that's where the various different equipment goes into.
Well, it is. In fact, the International Space Station is a cooperation between different space agencies. NASA, the Canadian Space Agency,
Woohoo!
JAXA, the Japanese one, European Space Agency, and also Roscosmos, the Russian Space Agency, is still cooperating there. What is the matter is that each of these space agencies has their own module in the space station.
Right.
I mean, they're making use of each other's modules, but mainly their activities focus within. So the NASA activities and the NASA instrument developments will be mostly placed within the NASA module, the US module.
Right. Right.
The ESA activities will be mostly located in the Columbus module. Then you have the JAXA module. Roscosmos has their own module, and as you can imagine, it's an opportunity, but it's also challenging to get everything working together.
Yeah. Even just the roommate situation's got to be, got to be interesting. Do you have to sort of ask
especially when it's getting crowded there?
Yeah, well, that's right, because you've got 2 extra astronauts up there right now, right? Is that until February?
Yes. Yeah. Yeah. Well, we I think recently 4 astronauts came back with a SpaceX vehicle, and then with the recent launch of a SpaceX Dragon, only 2 new crew members came back.
Right.
So they can bring the 2 Butch and Sunny. They can bring them back on the Dragon vehicle.
Wow.
So I think now there's about around 10, give or take 1 or 2 in the station. Yeah.
I feel it's a bit like getting stuck. For me, it would be a bit like being, oh no, I'm stuck on a wonderful tropical vacation for an extra couple of months. I know it's not as obviously exotic and fun as that, but the idea that you get to spend even more time on the space station has got to be a somewhat, exciting. Though it seems like the people who are going up and doing this stuff would probably be the same kind of people who would get excited about the fact that, great, this is just a new adventure. I got to figure out how to last.
Yeah.
I mean, it's I don't sense a lot of people going like, more time at the space station.
No, I think it's the first. It's just being excited that they can extend the stay there, and I mean, of course, what you also see is that all the crew members which are going to the space station, they are very well trained.
Yeah.
So that means, and we're going to talk about it later. I can show you something about that. That for the metal 3D printer, that the Sunny and Butch, who were launched with the Boeing vehicle, were not planned to work on the metal 3D printer because of their extended stay and the opportunity to have more crew time, they could effectively be asked to do work on the metal 3D printer. So they're extremely well trained to actually cope with this kind of changes you have to the people on board the station.
Well, okay. So let's get into this then, because everyone I've mentioned this to, I went in for I had this pulmonary thing where they were testing breaths and in and out, and I was geeking out with the guy, asking him how this works and why using nitrogen and stuff, all sorts of interesting geeky stuff about how the body worked. And he said, "Well, what do you do? Why are you interested in this?" And I mentioned sort of a little bit of podcasting and my nerdy, my tech bandits and stuff. And he said, "Oh, what sort of stuff are you doing?" I said, "Well, tomorrow I'm talking about 3D printing in space." And he's like, "That's impossible. How would you do that? I don't know how the whole concept of it." I got to explain to him because we'd spoken a little bit about it, but I just can't get my head around the idea that I get 3D printing. I have a number of them sitting here. I love the whole concept of 3D printing, but zero gravity. I mean, surely that throws a few additional issues to this stuff. How does this work? And I guess, why does this work? Why do we even want to do this?
Let's first answer the question of why do we want to have or a 3D printer anyway
Yeah.
on board the ISS. Well, I think the first thing to say is that this metal 3D printer and we also had plastic printers on the
Right.
ISS. They're not so much there to make sure that we can print spare parts, that we can print special tools, etc. It's all there to familiarize with the technology and
Right.
exactly ask questions like what you're asking. How can we print in space? What is the quality of what we print? So
Yeah.
we have to do experiments to familiarize with this.
Mm.
And this is the reason why we have done this experiment. It's a technology demonstrator. We want to learn how do you operate a printer in space.
Mm.
How do you get the quality that you can actually print spare parts? And the reason we want to do that, because if we're going to extend our missions to the moon and to Mars, you see, today, if something breaks down, and even if we have crew members stuck on the space station, a few months later we can send a Dragon, we can send a supply mission, and we can supply to the space station. It's early days they used to take 4 or 5 days to arrive at the space station with the orbits, etc. Now sometimes they're there within a day and they can attach to the space station.
Wow.
And unload. So there's not really a reason why we should have to print this on space, because it's expensive. It requires an expensive instrument and an instrument which is bulky. It's large.
Mm-hmm.
But once you go to Mars, then you cannot resupply anymore.
Yeah,
because
those deliveries start
you have
becoming
to send
yeah.
you have to send a container with the same speed to Mars as the space habitat, so it will never reach it. So you need to have something on board, and then of course you can think about make things as reliable as possible. And it's going to happen anyway. It's happening today. We make everything as reliable as possible, or bring a lot of spare parts, but you cannot bring all the spare parts you need, because then you basically need to have a warehouse with you to be able to collect your spare parts. So 3D printing in space it offers a very interesting alternative. And but yeah, I mean, we do need to go through a lot of steps before we can say, okay, we can really manufacture spare parts in space.
And they've used it. I saw there was an article fairly recently about. I mean, it was something fairly trivial, but it was like they needed the right size wrench for something, so they 3D printed a little hex wrench that would work for them. I mean, that saves an awful lot of money. Those deliveries are also not cheap, right? There's a robot. Those are serious rockets going up. Robots. I got robots on my head. Talk about 3D printing for a second here, because there's a number of different ways of approaching 3D printing. I know we've got, I think the ones that most people are familiar with probably is literally just melting plastic and moving the head around to create. It's basically a giant glue gun that you can slowly put layers down. And they're extraordinary, wonderful stuff. Is that the same kind of approach you're taking with 3D printing there? I mean, I guess there's and also, how is 3D printing being used? I suppose there's a number of different ways, right? I mean, we talk about the metal one, that's the new one, but they've also been talking about using that to build habitats potentially on the moon, and So maybe let me know, what are the types of 3D printing you guys are using there? What are the focus?
For the metal 3D printer, we are using a technology called direct energy disposition. So basically, what you do is you heat an area of your your printing area. You heat the metal, and when you heat the metal, and we do it with a laser. Yeah. But you can also do this through electricity. You can do it with a coil.
But lasers look so cool. I mean,
it is. But be careful with a laser, because we have a 1 kilowatt laser there, and it has to create a temperature of 1,400 degrees Celsius to be able to melt the metal.
Yeah.
So, and then what we do, once we melted the metal, we put a wire in it. The wire will melt a little bit. We retract the wire, and then this melting pool, together with the wire which we added, will solidify and add some material to what we call a base plate.
And how do you stop it from floating away? Like, how do you stop? Because if you're actually melting stuff, why is it not? We've all seen the movies where the stuff floats away.
Yeah. Well, partly because of the internal forces in the metal, the attraction. It's the cohesion of the metal melting pool with the underlying metal. That's quite strong, and that's very strong as opposed to that you're only melting a very little area. So the mass of that area is extremely small.
And it basically holds itself together.
It holds itself together.
But if you did too much melting, it would become a blob and float off.
We've experienced that. Yeah.
Oh, really?
Yeah. Yeah. We managed to get rid of the blob because we experienced it. But that's part of what we want to learn.
But how do you get rid of the blob? Does it literally take one of the astronauts to go in and grab it and how does that? What do you?
No, we actually use the laser for that. We use the laser to cut the blob from the wire. Yeah.
Oh, that's great.
Yeah.
That's got to.
Or we create a melting pool on the material and we melt the blob in the. So it depends a little bit on the situation. Ultimately, if we would not have been able, we were able to do this, but if we would not have been able to do this, then we need crew to open the sealed container where the printing is taking place.
And that's not generally what I mean. I'm guessing that's not as simple as just like oh, it's done.
No. It takes about 4 to 6 hours for crew to retrieve the printer from its location, open the sealed container, because the printing needs to take place in nitrogen.
Right.
So you cannot print in oxygen because then it will burn. Right. So we have to create kind of a vacuum chamber or a sealed container where we remove the air and we put nitrogen to be able to print. Right. And so we also need to do a lot of preparations before crew can even reach the wire to cut it.
Right.
And that's
so it's all autonomous, basically. For the most part, you try to keep it all self-contained. It works for it. It looks after itself. How you're monitoring it with cameras and stuff internally?
Yeah. We have a video camera, and I mean, I might be able to share a photo from that.
This is our genius setup that we think we
get it for you.
I think if you can print 3D metal, if you can 3D print metal in space, I should be able to at least live stream your videos on it. I feel I'm really letting the side down if we can't do that. Though I wouldn't put it past me, to be honest.
Well, let's see if I this is.
Well, while you're doing that, it's the 3D printing thing for me. There's a wonderful kind of fascination. There's a magic to it in a way. I used to joke that you could watch an ocean forever, you could watch a fire burn forever. Then it became like, oh, babies sleeping was something that was just wonderful to watch when it's your own child, especially because they're sleeping. And then 3D printing. I could watch 3D printing, and I will often just sit there watching these layers get put down. There's something almost sort of primal about this idea that there is a machine building something for me. You know what I mean?
And it's done from ground. It's done, and I will share the. I hope it works.
Yeah, this is great because then you can actually. And when you guys see this, it's just. I mean, yeah.
So basically, what you see, this is real time. So this is not. I can show it later, but this is what happens. So we have a video camera there, and then once we have printed this, and this is just prints like the lines which are done prior to when we're going to start the sample, the real sample, because we want to check, is this printed okay? I mean, you see here, you see the lines, and some of them are not printed that well. Right. So then we can make corrections.
It's your layer test. You're doing a layer test on the. That's
exactly.
Right.
Yeah. And so we have a video there, who's also taking the pictures to see, and then there is a laser. A small power laser who scans the surface of the print.
So when we're seeing it, when you're seeing it lay down this layer of, it's a stainless steel? You said, is that right?
This is stainless steel. Yeah.
So the laser is above somewhere, or where is it actually? Yeah. Okay.
This is the focal point. So the heated area is the focal point of the laser, but the laser the laser objective, so the which focuses the laser on the printing area, it's about 5 to 10 centimeters away from the printing area.
Wow. Wow.
And you have to be, and that's also for a reason, because I mean, you can imagine you have to heat up the printing area to about 1,400 degrees centigrade Celsius.
Yeah.
So
wow.
if this is going to, if the laser or the sensors would be too close, you might actually damage the optics of the laser, optics of the sensor, etc. Right. So we have to really make sure that this is kept up and running during the printing.
Well, and I guess the other thing you got to keep in mind, which you obviously are, is that this is sitting this whole this whole experiment is running beside people living in space, right? I mean, so it's got to be it's got to be the safety has got to be. You must have thought of everything. I mean, like you've just basically got to go. What if this goes wrong? What if this goes wrong? What if this goes wrong?
Exactly. There's procedures for that to go through all the what are the possible hazards which could happen, and especially when you have a laser, then our safety board is very, very.
My wife made me buy a fire extinguisher because I started using the laser cutter here, and she's like, "No, you need a fire extinguisher."
That's the reason for that.
That was it. Yeah. So,
and also I mean, if you're printing metal, there's certain fumes which are from the metal, which could be toxic.
Yeah.
So you also have to make sure that you have the proper filtering, etc., etc. And this has been a discussion when we had this kind of bulb on the end of the wire.
Yeah.
We wanted to see whether we could cut it, and even cutting the wire needs a safety assessment whether we can. So we very much value the well-being of crew as well as the space station itself.
Right.
I mean, can you imagine that if the laser would go out of the printing area and hit the wall of the space station? I mean, don't even think about that.
My Stargate character might have done something like that. I could see. Oops, but sorry, I took off that part of the space station. I mean that's. Yeah, I mean, God, the more I think about it, the more I think I struggle to figure out how you make something like that happen. What is so ESA? Are they? I'm assuming they've just got a series. They've got a system in place that people just run through everything they have to do. There must be some kind of a system in place for that.
There's procedures in place which when you basically have the idea. To start developing a metal 3D printer.
Yeah, whose idea was this? Where did this come from?
That goes far back. I think it's partly it comes from discussions from when we're talking about the future of space exploration and what's needed in support of that.
Right.
People will come up with, okay, we do need an in-space manufacturing capability.
Right.
We need to. I mean, you were talking about on the moon when you're trying to build habitats there.
Yeah.
Is 3D printing an option with the zeolites which are on the moon? So at some point in time when you're going to look at what's needed to do in-space manufacturing, the idea of plastic printers, metal 3D printers, but also post-processing equipment. I mean, we're also trying to support circular approach. So maybe we can recycle failed components. So
that was fascinating. Yeah, that was mentioned early on with that, wasn't it?
Exactly. So the ideas are coming from, I would say, overall high-level discussions on future exploration strategy and what's needed in support of that. Another thing is, how do we feed crew who are going to Mars? Because it's a 1.5 year trip.
Yeah.
Then they have to wait for half a year, 1.5 year back. How are you going to feed them?
Yeah. We've got to be growing stuff, right? We've got to be able to create our own food, right? I mean.
Yeah, but there we also have this sometimes crazy idea. Can we use this concept of cultivated meat? Can we use this concept of proteins which are produced by using bacteria? I mean, what is the footprint of these kind of technologies as opposed to bringing everything? So, and we're in the early phases of exploring these kind of technologies, whether they would work in space. And in this respect, this is looking at a 3D printing metal, and it's like, okay, we're starting from scratch. What do we need?
Yeah.
What do we have to take into account? And of course, the samples which come back from space will, and I can maybe show you a
Yeah,
picture of
what are you
the.
printing? Like what? Yeah, that's so you've got your first print of a metal printer in
Well,
space.
that's why you say, well, when people were asking you, well, it's not possible to print. I can safely say, without any hesitation, yes, we
You've
can.
got photo proof. Look at that. Look at that.
So this is printed, and we also got questions. I mean, what's this? These are tensile and bending samples.
Right.
So why are we doing that? It's to understand what is the quality of printing. So
Right.
these stress samples and these bending samples, they will be removed from what we call the substrate, so the base plate.
Right.
They will be machined to certain dimensions, to predefined dimensions. And if we have these samples, we're going to pull them apart and see how strong are they.
Right.
We're going to bend the small ones,
Yeah.
bend them, how strong are they? And then we're capable to compare it with what we have printed on Earth.
Right. So you've done the same print on Earth.
Yeah, we've done it already.
And so I guess the cleanup is just to make sure that everything is a consistent like width and height and
exactly.
Such, right? Yeah,
so
okay.
we can I would say scientifically compare them and
Wow.
make some initial conclusions about the quality of printing in space. So
Right.
I think that is one of the things we really want to get out of this. And by having printed this part, and we're printing 4 parts, we're printing now another sample which looks different, and then there's going to be 2 others. But by having printed this one, we can already start investigating what's the quality. The other thing we wanted to know is, how do you operate such a thing? How does crew? What do we learn? What do we have to take into account?
Right.
We've missed a few things in the development we know now. So when we are going to do this for real, I would say. So when we're really printing spare parts, then we can do this a bit more reliable than what we have done now.
Already, just from what you've achieved so far.
Yeah.
Wow.
I mean, I'm amazed. This has and. I will have a reservation with that.
Uh-oh. I didn't. Is it a trick question? I asked you a trick question.
No, it's not a trick question, but we got the question. This took 25 days. And now people will tell you, because you saw the previous movie, and you see that it's actually the printing itself is going quite quickly if you look at it real time. This took 25 days, and there's a few reasons why it took so long. First of all, we're not allowed to print longer than 4 hours, approximately 4 hours per day, 5 days a week.
And that's because
the machine makes a little bit of noise, and so
it's a little bit of noise.
Right. And there are limitations,
right,
depending on how much noise you generate in the space station.
Right.
How long you can operate per day.
Right.
So now we're discussing with our international partners that if there's no crew in the Columbus module, would we be allowed to print a bit longer?
Wow.
So
this is a bit like having the list on the fridge with your roommates saying like who's got the PlayStation tonight? Who's got the
Yeah. So this is one of the reasons. The other reason is that, I mean, these. You see a little bit in this photo, you see that there's layers.
Mm-hmm.
These prints are 218 layers.
Wow.
And after each layer, we want to have a video recording.
Right.
We want to have a surface measurement to see whether we are printing in line with what we would expect.
Right.
These have to be transmitted to Earth, which sometimes can be done directly. Sometimes it takes a little bit of time before we get them on the ground station.
Right.
They have to be analyzed, and based on that, they say, okay, we continue with the following layer.
Wow.
So now one of the things we're actually discussing to do, maybe not in space, but we also have a printer on ground, is to see whether we can use some automation together with a digital twin. So we do some artificial intelligence who can actually analyze the video and the surface measurements and directly determine, okay, then we print it like that. And then and if we print 24/7, we're going to substantially reduce
Right.
the duration of
Right.
printing.
The digital twin thing is hilarious to me because I just think whoever used that we have to come up with a better term than that, because that is just so ripe for sci-fi to destroy. There's always there's always one evil twin, right? So you know,
It also took me some getting used to the term, but
it's an odd
yeah,
term, isn't it? It feels like it feels like saying, in a way, robot now, or
yeah,
automaton. You know what I mean? It almost feels dated, but no, but it's such a great tool with a terrible name, because it just allows us to do things faster than it takes in the real world. I mean, that's
yeah,
I know with robotics, it's a big part of it, because the fact that you could have a robot run a test 1 billion times overnight. In the real world, there's only so many hours in a day that you could get a robot to run that test. So,
exactly. Yeah.
so interesting. So you'd be using AI to basically, like, right now, are people literally just looking at the photos and going, "Yep, okay, great, next one."
Yeah, yeah.
Wow.
The AI is now still with humans. Yeah,
Really? Okay.
it's
Wow.
that's we're thinking about the next steps could do this, but yeah, and it was consciously we did this that now humans are looking at it because we want to learn from it. So also the people are building knowledge about, okay, how are we going to do how are we going to do this, and how are we going to correct. So also the team, and that's a team which is working from Toulouse in France.
Oh, great
Uh,
place.
are
Fabulous place. Yeah.
yeah, yeah,
Yeah.
yeah, yeah. Pink City.
One of my
Yeah,
favorite conventions was there, the Toulouse Comic Con.
yeah.
Yeah.
Yeah, I'm actually I'm hoping to be there early next month
Oh,
again,
great.
to also to witness the day-to-day operations for printing, because once in a while I prefer also to be in that environment rather than in the office environment here,
Right. Right.
and
Right.
get the pictures at the end of the
Gets you out
day.
of the office, gets you a bit of French food. I mean, come on.
Exactly.
Yeah, pick up the cheese. I love the cheese.
Yeah.
Agna, our fabulous Agna, who's basically spearheaded this entire thing, has volunteered to check the questions for us, because in the chat, because she knew that I was going to be I was going to be asking lots myself. So there's a number of questions here. Why don't I ask them to you? So Martin asks, hello Martin, says, how fast is the metal printer on the? Oh, we sort of touched on that. It can go faster, right? But I'll let you.
Yeah, yeah,
I'll let
yeah,
you answer it.
yeah. Well, I hope that the first video showed a little bit on how fast I'm. Uh,
Do
I
you
think
have
you.
it again? Could we see it again just to see
Yeah,
that? Just
yeah,
so
of
we can sort
course.
of.
That's then I can also tell you a little bit about the size of what we're printing, because
Mm.
that I would say is information which is. Let me see if I have it.
It just
I
never
had.
hurts to have the lasers melting metal in space. It's just always kind of a fun thing for people to watch. We should
Oh,
just loop that video.
I can keep watching this all the time, and
Yeah.
I have another video of actually what we've printed, but that's not a video. It's a GIF, and when I open that, it's only pictures, so it's very difficult to share it. I
Mm.
should have prepared that a little bit better.
No, this is
But
great.
when you're looking at the S, it's in the order of half to 3/4 of an inch. It's two
Oh,
centimeters
really? I didn't realize
approximately.
this. Okay, so it's a fair size.
Yeah, the sample I showed you, the picture which was held by crew,
Mm.
we can print a shape within the volume of a soda can.
Right.
So
Right.
and that's of course that can be extended, it can be made smaller,
Mm.
but this was what we choose for this technology demonstrator.
Well, and that's how the 3D printing, the whole consumer 3D printing thing started too, right? It started with these smaller printers, and they've
Exactly.
gradually got
Yeah.
larger and larger and
Yeah.
larger,
No,
and
so
more of them. My
mm,
joke is always that there's no, like tattoos. No one ever gets one 3D printer. Like, no one ever gets one tattoo. They always, I always have to have, like, and I end up with 1 million 3D printers and no tattoos.
well, let's see at the end of my work at ESA whether there are multiple metal 3D
There you
printers.
go.
I
That's
might
it. Then there you'll know.
might not be the case.
So Martin, hopefully that answers your question. You've literally seen how fast it can print. That is it in action there. But the need to quality control and safety and stuff means that it's obviously a slower process than what the machine is actually capable of to start. Nixie. Hey, Nixie. Nixie's got a question. It says, I hope ESA is a good place to work. What was your most fulfilling day at work there? Ah.
Now, I can only confirm that that working at ESA is extremely interesting. I mean, I'm in the middle of everything what's happening on the space station, being in that day by day. Sometimes also working with the people who've been there to understand how they've experienced the projects, the activities. So yeah, I mean, I do appreciate very much to get on the bike or in the car in the morning and go to work. Most fulfilling days, I think the one when I got the video which I just showed is that we managed to get after 5 or 6 years of development with all kind of challenges to manage to get the printer on board and to see the first actual print being done. This because I must honestly say it was fingers crossed because it is a technology demonstrator. We used a lot of commercial off-the-shelf equipment.
Really?
It's I mean, safety is very strong, but in terms of reliability, we really were trying to keep the budget as low as possible to learn. So to see this, and then the second best day is when the first sample was returned from the printer by the crew, and everything worked.
Yeah, that's amazing. I mean, I can verify this. Whenever I talk to Rob, he looks annoyingly happy all the time.
Is it annoying?
No, just because I'm jealous. That's all. Yeah, it's cycling to work at ESA just sounds like a dream. It sounds like magical. Nixie, all right.
I have to live up to my nationality here, David.
That's it.
Dutch, so we cycle.
That's true. You got to cycle. You don't have a choice. I've got to eat bacon. That's all I have to do because I'm Canadian.
Okay.
So thank you, Nixie. All right, AB solution. EAB, yeah, very good. AB testing. How are the metal printers powered on the space station? Yeah, power was actually one of my first questions. That's true. Yeah, maybe you could explain how the power situation works on the space station.
I think the first to answer is that in general the power supply on the International Space Station is coming from the solar panels, which are on the station, and please be aware. I don't know how many kilowatts they generate. You can find it on the internet within a moment, but they're the size of a few football pitches. Yeah. So they're huge,
just
and they generate
from the sun.
Yeah,
that's another technology that just blows me away. Like
and it's amazing how much it generates, and then the power which is generated by the solar panels is then distributed to the different modules. So the US, the JAXA, the Japanese, the Russian, the Canadian, and the ESA module. And then within that module, there is a power distribution to the different instruments which are in the Columbus module. And to make it very precise, for the metal 3D printer, we have about a budget of 2 kilowatt.
Wow. And so they must be. They're storing this power? Do they store the power on the station, or is it all just directly from the sun?
That's good. I think they might have some batteries, but mostly they need to have the batteries for the time they're in the shade of the Earth, and don't have the because they're not in a polar circular. They're more or less have some outages and dark sides, and then they need to have the continued generation. So yes, they have batteries.
But so when you're running, you're probably not running the metal printer unless you're actually directly getting that power from the.
Well, no, we are running the because if you're looking at 3.5 hours of operation of the metal 3D printer, one turn around the Earth would take about 2 hours.
Yeah,
so,
I keep forgetting it's moving crazy fast, isn't it?
Yeah,
it just looks all floaty and peaceful.
It's about 6 kilometers per second or something.
That's also.
I 2 years ago I gave a present or just an introduction on a primary school and also for 6 to 9 year olds, and just to make them understand the concept of the speed.
Yeah.
These stations are going at it's basically you tell them, well, from my town to the airport, which is about 20 kilometers, it takes you 3 seconds.
Yeah. God, yeah.
It's, yeah.
I mean, you're literally hurtling around the planet. It's
Yeah.
just, and 3D printing at the same time now.
And you see quite a few sunrises and sunsets per day.
Yeah, yeah. It gets boring after a while. Here's another one. Wait 5 minutes. I'll be doing one. Okay. Thank you, AB Solution, for that one. Martin has got a lot of questions today. Do you also do a standard? Is it fused deposition? FDM? What is that? I can't remember the term.
Yeah, that for me is also
standard FDM printing, either for yourself as a hobby or for ESA. Oh, there you go. So are you doing 3D printing yourself? I mean, is it something you use in your sort of day-to-day?
Nope.
No.
I think it's extremely interesting, and sometimes when I pass a shop where you have these plastic 3D printers and you can see what you do with it, I'm thinking, yeah, this could be interesting, but I also found out a few years ago I have to make choices.
You should maybe print a space station, even just so you've got one for yourself. So a little, something. I keep meaning to do a print of it. I've got the rover somewhere.
That would be nice, and quite honestly, you also have the opportunity to make your design and go to a 3D printing shop, like a printer shop, and just do it there. For me, it was also a bit of a choice of, okay, where do I focus on my free time, and I'm sorry to say that 3D printing didn't come in first. Yeah. So
you're doing that. That's your day job. That's You're not going to go home and your hobby is not going to be that as well. And also, if you're
for ESA, we do have 3D printers here, and we're making use of them. Marty, maybe what is also good to mention is that we're not only investigating as ESA 3D printing in space, so actually making spare parts in space, but we're also investigating using 3D printing solutions to print parts for rockets, for satellites on Earth when we are building them.
There was a company
shapes.
that was doing metal printed.
Yeah.
Are you guys using that?
I think there's even a company, and we discussed it during lunch yesterday, but then my memory is failing me here again. There's a company who's recently 3D printed a rocket engine with all the tubes inside, with the cooling inside, with the guidance inside, and they're actually doing tests with that. So. Wow. Yeah, a colleague of mine who is working more towards the technology support and the material section, he is looking into all kind of space or 3D manufacturing solutions to be used when we're developing equipment. But in the end, there's a lot of benefit to printing things in space, because if you print things on ground or you manufacture things on ground and you're launching it, you need the stuff to be very strong because it has to survive a launch. And if you print it in space, you don't need this strength anymore. So you can print at much lower mass, and that opens a lot of opportunities. But yeah,
there's
that's
some medical
for the
printing
future.
too, isn't it? They're doing some medical printing on the station that basically can't be done unless you're in zero gravity. I mean,
it's nice that you mention it, because one of the projects, and I'm actually a bit disappointed that I'm not involved in that, but we're developing a 3D bioprinter.
Yeah. That's amazing. That stuff is extraordinary. I mean, it's funny. We had a discussion about this. I did a panel on science and sci-fi with a sort of more of a focus on biology over the weekend. And one of the things that came up was the idea of what do you think? What about the future of bioprinting? And I was saying I felt we were more going more into the realm of these chimeras, these using other animals to create them rather, because the 3D printing is such a detailed and lengthy process. But the idea that it can only be done up in space is fascinating. I mean, so you couldn't jump ship from metal to bio. You couldn't do that.
Well,
you're working on it.
Unfortunately not.
But you're now the pro on 3D printing. Can't you sort of go been there, done it? No.
I would actually love to continue with the next steps.
Yeah. What are the next steps? What is it? So you've done this. I mean, you print a space station next? What's the next?
There's a few ideas, and I'm afraid it doesn't reach to printing a space station yet.
Right.
It's just, I mean, you saw the quality of the print.
Yeah.
Let's also face it. That's that needs improvement.
Yeah.
So we're looking into that. As I said, we're looking into automation.
Mhm.
We're also looking into post-processing. So as soon as we've printed some things, do we need to process it? So we're really looking at the manufacturing process itself. So how the 3D printing itself, then today on how we're going to use it to print. For now, this kind of printer is more for spare parts, small tools, or small construction parts.
And like a proof of concept.
Yeah.
Yeah, that's not
So this will be the next steps. I mean, it's very much depending also on when a mission to Mars becomes reality. I mean,
Right.
there's a lot of activity going on to see how this would work, but there's also still a lot of investigations needed to see that it would actually work.
Right. Right. And it's, I mean, but basically, once you've got once you've got a working prototype, it's a matter of just making it larger, right? Is that like I mean, once you've got once you've got something that can do the precise parts you want, you can size it up. Will that have an effect? Like on Earth, I know with gravity, the larger these things get, the harder it is to make them more precise. Is there the same limitations when it comes to
there's, I mean, definitely you can resize. To what extent? I think you have to realize that we are printing in a sealed container, which needs to be strong. And as this gets larger, it gets more and more challenging to make these kind of sealed containers, especially when you're starting to work with pressure differences. So this is one which could be a limitation. Then of course you need to move the sample with respect to the laser. So how much space do we have there? And one of the issues we actually encountered is that the further we came with the sample which we have printed, the more challenging it became to get rid of the excess heat when printing. So when you're looking at, and maybe
as it gets closer to the laser, it becomes harder to get rid of the heat, or the heat is just transferring down.
No, the laser is always at the same distance from where you print.
Oh, right, of course it is.
That's done in this, but it can change. But if you're, I'm going to share this because then maybe with my pointer I can explain it a little bit better. Because this is the base plate. So when you start to print here, your heat gets immediately to the base plate. So you have a lot of volume. But when you're printing here, the heat has to go through.
Of course, it's not going to dissipate nearly as fast, is it?
Yeah. So we do have an airflow to cool it down, but it's going to be more and more challenging. So that when we had the movies of printing this, then we saw that the closer we came to the end of the print, you saw the remaining layer still glowing a bit from cooling down.
Oh, that's fascinating. All these little things you just wouldn't think of, right?
No, and to be honest, this is also something which, I mean, in space when we're developing satellite, we try to think of everything if we develop it, because we have one chance to make it a success.
Right.
With the metal 3D printer, this was a little bit different, and we also took that approach a little bit different. So this is also something we discovered when we were looking at the video, and people were saying, I mean, things are still glowing. What's the matter? And then analyzing this, we said, yeah, but we have to, for next time, we have to see how we can solve this.
Right. God, yeah. I mean,
that's fascinating.
It really is, isn't it? And the fact that we're talking about airflow in a place that there is no air. You know what I mean? Like this. So you're like, oh, okay. So how we?
Yeah.
I mean,
it's. Yeah.
And was there a reason? I think I asked this, and I can't remember what you had a obvious answer, but I can't remember what it was. That I was like, it's you're printing in the space station. Is there not a way to use the fact that it's freezing cold and there's no air outside of the station? I mean, is this something that was the reason why? Like, why do the 3D printing in the station? Because you have to get to it. Was that it? Is that purely just a matter of that?
Yeah, I mean, for this specific 3D printer, this was one of the reasons, is that we need crew to install it. Uh,
Okay.
and there I might
I always
actually
think of it
be.
as so much more automated somehow, but I guess the fact of the matter is you still need people to plug things in and and screw things down and all that kind of stuff.
Yeah, but yeah, you st- you still need it in the station to because it's a technology demonstrator. When we go to a next step, we might see whether there could be a mechanism which is automatically capturing the printed part and placing a new base plate for the next part.
Right,
That
right.
could very well be, but
But keep it
yeah, at
simple to
this
start.
moment, yeah, yeah,
Yeah, it's so basically this is. I mean, in the 3D printing world, they talk about printing benchies. Have you heard this? The benchy is basically a little.
no?
It's just a little ship. It's just a little
Yeah,
ship that just basically that it's a standardized way of looking at a 3D print. I don't actually have any
okay,
because I think I got rid of them. But they're literally it's just a little 3D printed boat. And the idea is basically that you print that on any printer you've got, and you can compare that. So basically, you printed your first
yeah.
space benchy. In the 3D printing world, that would be,
That's
that's what it would
actually
be.
well. I mean, that idea is actually very good, and something we can take along is that all along the printing you're doing, that you have some kind of benchmark or reference where you
Yeah,
say, okay, how does the next generation of 3D printers in space compare to the one we had, and
yeah.
how does the quality improve over time? So yeah, that's actually very good concept, and
There's with the
yeah,
FDM printers, it's really funny to see like the first ones. There was definitely you could definitely see layers, and as they got progressively, more and more sophisticated, the layers disappeared, and then you get into the whole, what is it? The God, what is it? What's this? The one that you drop it in the fluid and it lasers the. God, what is it called?
is it that's not deposition, that's
No, it's the opposite of it's the other one. I never get the term right. We should go back to questions. Sorry, because I'm hogging you totally here. So Martin, no, not a lot of hobbying of. You're actually this is actually a great segue for your hobby actually, because Rob is huge on wildlife photography. Um,
yep.
and that's what you when you want to get away, that's what you do now, right? I mean, that's your
Yeah. When it's just in the spare time when I just want to disconnect.
yeah.
I go hiking with the camera in my backpack and yeah, see see if there's something to capture or not.
And
And
the photos are just beautiful too, just absolutely
thanks.
gorgeous.
Yeah.
Yeah. We'll have to do. I was gonna say we should do like a whole other like genius chat about just that aspect of things because I just love the fact that you're cycling to work to do some of the most sophisticated, complex stuff that humans have ever done. But on the way, you can stop off and take some photos of like foxes and things. You know what I mean?
Yep.
It just is idyllic.
Yep.
I've got this wonderful. I don't think it'll ever live up to. If I ever visit, I don't think it's ever going to possibly live up to this fantasy world that I have built around it right now. Okay, another question. What are the steps from design to final part for a metal 3D printer? I know from experience that it's quite different from FDM. So what are the steps from design? What do you design this stuff in? Is there a software, or is it just literally just programmatic at this point?
No, well, we start usually from a cut drawing. So
Yeah,
from any cut drawing, there's a standard format for that,
yeah.
and then
Are these
the industry.
STLs? Are you using STL files for it? Is it?
I think it's an STL
Is it?
file.
Oh
Yeah,
wow! Oh
yeah,
great! Wow. Okay,
yeah.
that brings it
So
home.
it's the standard exchange format for 3D
Yeah, yeah.
designs,
So G code
and
stuff.
then
Yeah.
this design is fed in through kind of a translator,
Mm,
which translates the 3D shape into what we call a G code
yeah.
sequence. And the G codes are actually the codes which are fed to the metal 3D printer.
Mm.
Um,
Just the
but that's
instructions on literally where to move and
exactly.
where to. Yeah.
Well, it's the instructions on where to move, and of course, this processing software needs to be tailored to the specific,
Right.
I would say, layout of the printer and design of the printer.
Mm.
Because in our case, this G code file also switches on the wire feeder
Right.
It says, well, feed the wire with 1 millimeter, retract it with 10 millimeters,
Yeah.
etc. It does the motion table. It
Oh,
switches the
right, because you got to
laser
move the
on.
table as well, right?
Yeah. It's also moving the table, and in the end, the G codes we have also automatically process or take the picture.
So and all of that is custom, I guess, custom G code you've got to build
Yeah.
into the system. Are
Yeah.
there, I mean, are there comparables? I mean, obviously you've got your own, evil twin back on Earth, but what about in the regular world? Are we using this technology for other things here? And are we doing a lot of like 3D metal printing? I mean, is that it's not something I'm really aware of. I've seen some welding stuff, but
No,
not.
we're definitely increasing the 3D printing on Earth.
Mhm. Of the metal.
And yep, metal.
Well, the rockets, obviously the rockets, but that seems
The
to be more
rockets,
of a sort of a.
stainless steel. I think in a few weeks I'm going to visit kind of a fab lab, a so-called fab lab here in close to where I live, where they do 3D printing, and they part of it is metal printing, and they recently got a titanium printer there.
Oh wow!
So yeah, that's so I'm actually very much looking forward to that, and I usually see it as kind of a cross fertilization between I would say the terrestrial application and the space application.
Right.
So we can use some of the and we benefit from using some of the terrestrial technologies,
Yeah.
because why should we develop it ourselves if
Yeah.
it's already available
Yeah.
on Earth? On
Reinvent
the
the
other
wheel.
side, yeah, exactly. Sometimes we also have to tailor it a bit, for instance, to meet the safety requirements, to meet the environmental requirements. I mean, one of the things we had is that in the station we are lucky to have a nitrogen supply,
Right.
but for instance, we don't have an argon supply or a neon
Oh my
supply.
God! Of
So
course. Yeah.
printing, we cannot use a printing methodology which uses one of these inert gases,
Right.
which
Which
is
is
not
what would normally
available.
be used in these
Exactly.
welding kits.
So
Yeah.
so we had to tailor it to using nitrogen as a protection to
Hmm.
prevent the printing from burning. Vice versa, we of course gain the experience now to do printing in this way, and we are also aligning them with the terrestrial
Ha.
applications to see how they can benefit from that.
So it
One of
improves
the
both, basically.
yeah one of the things which I think it's very close to my heart, and that's with other things in space business also. One of our challenges is that we have to make it small.
Right.
We
Right.
cannot we cannot. This is about a meter high,
Yeah.
uh,
Yeah.
40, 50 centimeters wide, and 60 centimeters deep. If you look into a factory a metal 3D printer, I mean, it takes up a room.
Yeah.
We
Yeah.
cannot fly that. So we've managed now to get this, and this is very exciting because we make it small,
Hmm.
which means that if this works in space and we could apply it in on Earth, then and maybe not the metal 3D printer, maybe it's a plastic printer, but if you have these small pieces of equipment requiring 1.5 kilowatts,
Hmm.
requiring maybe some cooling. Maybe if there is an emergency area somewhere in on the world
Hmm.
because of a natural disaster or something, and something is needed to quickly deploy constructions,
Hmm.
you have a small piece of equipment
Yeah.
which could actually be done there. And that's also part of I would say, the cross fertilization we have it. We
Hmm.
also do this with the same with the food solutions.
Hmm.
We need small solutions for producing food for crew. I
Right.
mean, why not use this on Earth in areas
Yeah.
where,
We do need
yeah,
to eat here too. Yeah.
yeah, but I mean, even in these emergency services, if you have a small piece of equipment, like maybe the size of a container,
Hmm.
which can quickly support in emergency areas people in need,
Hmm.
then you can benefit from these miniaturized technologies.
And
So
it's self-contained technology too, right? I mean, because
exactly,
it's
yeah,
designed to be modular for the station, it
exactly,
becomes that
exactly.
modularity, I
And
guess, is
3D printing in metal might not be the first thing you think of when
right.
you're going
Right.
into an emergency response, but still, the fact that we're developing miniature solutions
Hmm.
for different technologies could be helpful there. And we're trying also to encourage industry to take up on that.
Yeah, how does it work with that though? Like, so you're inventing this stuff is being invented by ESA and in partnership with, is it Airbus? Is that right? Was this
Now
one?
I mean, ESA is an agency. It's a procurement agency. So we draw up a space program, and every 4 years we get funded by our member states, which at the moment there are about 22 member states.
Right.
Most of them, if not all, in Europe,
Right.
to a large extent overlapping with the European Union. And we agree with these countries a program of different activities, and then we contract these activities based on the funding we get from these countries. We contract these activities to industry in Europe.
I see.
And
Okay.
in this case, Airbus is it leads an industrial team who have developed the printer for ESA, and
Right.
then they
Okay.
deliver. So ESA is the owner now because it's been delivered, but it's been developed in industry.
But does that mean like patents and stuff can be made public, or I mean, how much of the stuff can be
On a case by case basis?
Oh, okay,
If we're really developing forward IPR in a project, so actually we're developing knowledge which could be commercialized in a project, then ESA has the right of use.
Oh, great. Okay, right. Okay.
But it's also the industry developing has the right to keep the patent.
Oh,
So
okay.
we will not be in a position to say to everybody, "Hey, this is what this industry developed. Here you have it."
There you go.
Unless this is there's a prior agreement to that. Any knowledge before is I mean, which is with the industry is the same.
Right. Okay. All right. All right. Let's go back to questions. What do we got? Aside from standard CAD/CAM software, we talked about the software. Any applications for Blender? I love Blender. So basically, the whole question is: aside from industry standard CAD/CAM software like SolidWorks, what other software would be in use, and are there any applications for Blender? Have you ever played with Blender, the 3D? It's open source.
No, that's why you see a few big question marks on my face. That's
I am fascinated by the open source tools that are out there, because one of the things I love with Tech Bandits is that I want to be able to show, I want to get people excited about stuff, but I also understand that not everyone's got the money to invest in these CAD/CAM softwares. Can be quite expensive. The Blender is an open source version, which is extraordinary at doing a lot of this stuff. It's a lot more complex than some of like the Fusion 360s and stuff in some ways. I mean, a little more futzy because it's open source, but I think we've touched on that. You're basically using standards up to the point of the G code, which then needs to be customized for the specific machine. But you're saying that they were designed originally in just classic CAD software.
Yeah. That's also the inputs we provide. So we have asked for the industry to print specific parts, and we provide this industry with sometimes a drawing only, but in most cases with a cut file.
Right.
And they process that. Sometimes they process it first into a cut file a little bit more detail, because we also do have a lot of discussion on whether what we want is really feasible. Because I mean, this is a 4D printer,
right?
So it has a 3D motion table and then a rotation. The next step we might also consider to be able to print even more complex shapes is to make it a 5D printer and also see whether we can, for instance, move the laser head. But that's going to be challenging.
Yeah,
so
I can't get my head around the code for that.
Yeah, I'm also in discussion now with Airbus on what would be just on the back of an envelope, but what could be ideas to how we could realize that, and would it be interesting? So we still have to balance it against what do we really need in the future.
And what is the pressing need? I mean, what is the sense the sense you get from ESA right now? What is there? Is there a focus? Is there an area? Like, I mean, how important is the 3D printing in the scheme of things there now? I mean, what's What's your sense?
3D printing in general, because you can you only need to bring material and you can print anything which is needed at that moment. So that's the advantage, and then you can either decide to do plastic printers or metal printers.
Do the plastic printers work the same way? Because it's the same idea basically. Things aren't floating away because they're held in place. Yeah. The surface tension.
And we had a few printers already back in 2014 on the station, which were mainly from NASA.
Right.
And yes, some part of tools, as you were saying. So this is one of the things we can do, and then the specific parts which have to be printed is very much depending on which spare parts we expect would be needed. Some parts have a limited lifetime. Maybe we have to print them after this limited lifetime.
Right. Like
you
gaskets
also
and stuff and all that. It's great for that sort of thing, isn't it?
Yeah. And you may also need it that when you have to do a specific repair in space and you don't have the tool, is to see whether you can print the tool on demand.
Right.
And also if you're developing constructions, and there I can't say what is the specific part, but depending on the construction, every large construction needs smaller parts in it to connect larger parts to be able to provide attachment points, etc., etc. And here a 3D printer, whether it's plastic or metal, I mean, metal is there for strength, metal is there for conductivity, but alternatively, if this is not really needed, then a plastic printer at this time might be a better solution.
Also jigs and stuff. I find like creating little custom jigs to hold things temporarily and stuff. I think the 3D printing is just fantastic for that kind of stuff. Agna has a question for us here, which I think is a good one. Airflow. So we talk about airflow. How do you achieve airflow in the space station?
It's simple. You use a fan.
But literally, that's it. But you're just using. But the air's. So you're using the air that they're using for just breathing in, and
No, I think this was indeed maybe I didn't make myself fully understand. And in the I'm going to share something because that helps explaining it a bit. Let's see if I have the right picture here. I think it's because I think I haven't shown the beast yet.
Here it goes. Here it goes. The secret is out.
So this is it.
Oh, wow. Oh, my God.
Yeah.
Oh, that's a nightmare.
It's.
Oh, my God.
Yeah. So.
Wow.
If you see this part, this is a sealed container.
Right.
This is, well, to put it popular, is where the magic happens.
Right. The rest of it is the nightmare around that magic.
This is the nightmare of electronics and liquid, etc., and all kind of flex lines, trying to get the cooling done, etc., etc. So here is the sample, which is on the motion table. This is the laser head.
Okay.
And here you see a fan. These are fans.
Right.
So basically, we close the sealed container.
Right.
So then the sealed container has just normal air inside. Then the first steps we do when we want to start printing is remove the air and replace it by nitrogen.
Right.
So then we create, and that's maybe the misunderstanding. We don't create an airflow in the sense of air. We create a nitrogen flow. So basically, the gas flow of nitrogen is created here and is cooling down. So this is how we create an airflow.
Is nitrogen better at cooling than air?
No, I don't think so. And the main reason why we have nitrogen is
that's what you need.
Is with the printing process, that we don't burn the print.
Right.
The oxygen level is going down to 0.15% or something.
Mm-hmm.
Let's see if I can check that. I have it somewhere.
So very, very low oxygen, basically no oxygen.
0.5% O2 at 0.88 bar. So we create a little bit of under pressure. So that means that the sealed box, the seals here are pressing against the box,
Right.
so we create a very good air tightness. Let's
Right.
put it this way.
Right. God, that is a beast. It
It
really
is,
is.
isn't it? Yeah.
And so what's required when that thing goes up, which unto itself is, I mean, I almost need a human for scale, given that the rotating head that you're printing on is the size of a Coke can, you said, right? Or it was a
Hmm.
can of pop, that you get a sense of the size. When like, no wonder you need astronauts. How much has to be configured once it gets up there? Like when it gets in there, what do they? I'm assuming it doesn't just slot in.
Uh, no, it doesn't. So
Wow, I
we
cannot get
need
over
to
that.
we need to remove a bit of brackets here. So here you see the blue parts.
Yep.
These will be installed to fix the motion table.
Okay.
So they survive the launch. These have
Right.
to be removed.
There's the
Then
styrofoam
we have,
inserts on my microwave. Got it. Okay. Yeah.
yeah, yeah. Otherwise, you might get damaged. So
Yeah.
we really ruggedize the the 3D table.
Mm.
Then there is a wire feeder which needs to be configured. Some caps need to be removed,
How much
and then
wire are you
basically,
bringing up? Is there like just a spool of it somewhere, or
yeah, the spool is in here. And this brings we brought 1 kilo of wire.
right? Okay.
So and we are using between 100, 120 and 200 grams for 4 samples.
Right.
So we are still left with some spare in case it's needed,
Right.
or if we're successful to start thinking about another sample to be printed.
Ah, that's exciting. Yeah.
And
Wow, that's extraordinary. So when it gets up there, it has to be connected to the system, and I'm assuming we talked about this before, but basically you are provided certain outlets of for power and air
yeah,
and such, and that just needs to be that is all just done manually plugged in, basically.
yeah, it does. I thought I had this ready, and if you allow me, maybe a few. Let me see if I have it.
Well, while you hunt it,
Because I have a bit of a short movie from actually the installation
oh great,
by our Danish astronaut, but I thought I had it. I mean, my apologies. I thought I
no,
had
no,
it
it's fine.
ready.
That's no. This is all a treat. We'll get whatever we can get, and we won't get upset. Nixie's also talking about has a question about the metal printing on Mars, and which is a great question I haven't even thought of. But is there research into the mining of steel and such on Mars, making the metal on that planet to do the printing with? Like, so you're looking to get one of the things you touched on, which I thought was fascinating, was the idea of using existing metal, which I'm guessing is from space trash and stuff. I mean, what?
Could be space trash. Could actually also be something from mining. Some colleagues of mine at the European Astronaut Center, they've managed to print a Lego block from zeolite, which is the moon dust.
Oh,
So
so
they
cool.
basically extracted the material from zeolite. Of course, they have some Earth-made zeolite there,
Right,
which is
right,
to a large extent based on of course the zeolite which was brought home by the Apollo
right,
cruise.
right. They've got a
Um,
room of the stuff, don't they? It's like a little playroom of the stuff that they've
yeah,
made. Yeah.
yeah, yeah. This. Yeah, I think you can call it a bit of a playroom
Yeah.
because it's playing there, melting the material, extracting the necessary components from that, and yeah, it's all to and within the space domain, this is called in situ resource utilization,
Hmm.
is to see whether we can actually use the resources which are available on the moon and Mars
Mm.
to support in producing stuff. And
Which we
that's
have to
also
do.
why we yeah, it
Yeah.
definitely
Yeah.
we can't bring everything. Well,
There's
but then it takes a long time.
another article I saw recently about a proposed satellite that would basically build itself in space. I know that's been done in parts before, but this is literally, they were talking about manufacturing the various parts as it went along, which just sounded
Yeah.
amazing. But again,
No,
it
but
seems like quite a jump from where we are with the 3D printing right now. We're not
yeah,
going to be
but
printing our solar panels anytime soon.
no, and because that is partly due to the fact that solar panels are composed from a lot of different materials.
Right. Yeah.
So you would need manufacturing capabilities uh, for all these kind of components.
Right.
It's the same as how one of the other challenges is how do we manufacture electronic circuits
Yeah.
on board. There are technologies there. I mean, we're monitoring at the moment a few companies who are looking into these kind of applications. Is just to print circuit boards on demand,
Yeah.
print electronic components on demand.
But in
But
space.
that's far more in the early stages than we are with metal and
Right.
plastic printing.
But it makes
Yeah.
sense, doesn't it? I mean, if you can establish yourself as the Intel of space, you know, eventually once we start getting out there and more of these projects happen, they're going to, you've got a captive audience. I mean, that's literally, you know,
Yeah.
it's absolutely fascinating. And then of course there's the asteroid mining stuff as well. The idea of latching onto an asteroid and just plucking out what we need from that as well.
Yeah, that's yeah. And there's companies who are starting on that.
Yeah.
There are startups in I think the US who are already anticipating mining asteroids, mining moon, and they find themselves in quite substantial interest.
Yeah, it's fascinating, isn't it? I mean, it seems
Yeah.
so completely far fetched, but we seem to be jumping, we seem to be taking these sort of leaps ahead now with this stuff. Um, so what's I've kept you for so long. I'm sorry, but
No,
so what
it's
is
okay.
what's next for you? Like, what is the next stage now? It's up there. It's printing. You know, what would you like to see happen as the next stage for this?
Um, different ways. The first is we have to see whether we can be successful in completing all the 4 samples we were
Right.
planning to do,
Right. How close are
which
you to
will
that now?
take.
Where are you at on that?
We're in the second one at the
Right.
moment.
And you're printing 4.
We're printing 4,
Right.
and we believe with today's planning, we could be ready around April next year.
Wow. Okay.
But then, and that's
Space
I mean,
takes
I'm
takes
sure.
a lot of patience. It's like you gotta have a certain
It is.
zen to you. No wonder you're out there taking photos of wildlife. You gotta like chill out for this stuff.
What I will show you is this. I'm not sure whether it's the movie or not. Um,
Bring that
because
back
that
up.
shows you the fact is that the printer is hosted in a rack. So here you
Oh,
see
there you go.
a photo of our colleague Andreas Mogensen, the Danish astronaut,
Right.
and this is the metal 3D printer. And I'm trying to see whether I can. No, I can't. This is the metal 3D printer inside what we call an experiment rack, a cabinet.
Right.
And this is a cabinet which can support different kind of experiments. And from April 1st or from April onwards, we're expecting another experiment to be supported by that rack. So that means that we have to be ready by April.
To pull it, to
And
yank
then,
it out and get the new one in.
yeah, well, we're discussing a few options. We can just remove it and trash it. So that means it's going into a supply vehicle and it will burn into the atmosphere because we've done all. Nope, don't be sorry. We still have an engineering model on Earth. We still have a
Yes.
copy.
Yes. It's
So,
true. It just feels
and,
like God. I just. Oh, yeah.
yeah.
You know.
Well, it's quite expensive to bring 180 kilos down to Earth.
Right. Yeah.
It's at this moment the indication I got it's between 50 and 100,000 per kilo.
Well, and I suppose
So
environmentally, it also makes more sense because you're trying to get that thing back down to Earth. With the resources required for that would be
it would be a lot.
prohibitive under
So
itself.
that's one of the. So we try to do the planning until that. Then we get the samples. We get them on Earth, and we have to start processing. I saw a question on what is the differences between what you print in space and what you print on Earth, and that is, I mean, it's the best question. But I can't answer that. But this is what we're going to find out in the next year, and then I'm happy to be joining you for a second time, because then I can tell you a little bit about, okay, this is really the results.
Yeah.
And what's the strength? But also we're going to look at with an electron microscope. We're going to look at the microstructure. We're going to look at different material characteristics to get an understanding of, okay, is there a difference? Maybe there is. And if there's a difference, is it better or not? Sometimes producing, for instance, proteins, other materials in space is better than on Earth because the lack of gravity. So the composition
doesn't have that. Doesn't sort of slump down.
Exactly. Right. So maybe we find it out in that way.
So we could be, who knows? We could be sending stuff up to space to get it printed properly.
People have been thinking about that. Yeah. I know a project who is planning to print fibers, optical fibers in space, because the quality is better there.
Oh, wow.
To be used for small distances with high throughput optical connections. Yeah.
Really? I mean, wow. I can't get over, I guess, the difference in the economy of getting stuff to and from space now has just completely changed since I was a kid.
It's changing.
I mean, it's become, I mean, we're not exactly at Uber Eats yet, but it's definitely feeling like there's a, especially, I mean, that SpaceX seems to have just revolutionized that stuff.
They definitely are, for instance, for the launching service, their services. I think they've been a game changer. Yeah.
But what's neat about this is you've taken it to orbit now. Like, so basically it's like, all that, the biggest, most wasteful part of this is these giant rockets blasting stuff up in order to get us out of the atmosphere. If we can start building this stuff out in space, wow! I mean, that's a whole other level. I mean,
and especially if but I mean, there's of course a lot of debate and discussions around how and under what conditions you should use space resources, like from a comet, from the moon, etc. I mean, there's quite a few treaties so there's still a lot also on, and I'm not the expert there, but on the legal side, on the which arrangements have been made there, but the potential of building something in space using in-space resources is getting closer.
Absolutely.
And it's being under investigation and development. Yeah.
It's funny how we get in our own way, though, isn't it? That we're already trying to figure out who owns what and who's allowed to do what to what. One of the things that I had this horrible feeling of like, well, oh gosh, I mean, like we're doing such a horrible job of managing this planet that was literally designed for us, like in that we are a part of this planet because it allows that. We've done such a bad job of that we've got sort of billionaires leaping into space in the hopes of going off to other planets and starting all over again, which just never made any sense to me, because I just thought like surely the resources would be better spent making it work here. But there's also there's a wonderful term that was used the other day where they said like, us going to other planets is a bit like we're the tendril. We're like an Earth tendril, like that. This is us. This is not we. Yes, we're humans and all the rest of it, but we are representing a planet. We are a part of this biosphere, and perhaps we are that green tendril that is reaching out to these other planets. And it just sort of changed the perspective for me. I suddenly went, okay, then maybe we're not the most horrible things in the universe. Perhaps we are this. Maybe we are that little sort of reaching tendril, which I think is just a wonderful image. Look, I have eaten up so much of your time. This is so fantastic of you. Thank you so much.
No, you're welcome.
I
It's a pleasure.
I cannot, like, I just cannot, I can't wait to hear what else happens with this. I would honestly I really think people would appreciate the wildlife stuff. You got to come and talk to us about the wildlife photography at some point too, because it's something that I've always been fascinated in, never had the patience for. Although I did once stand in a very mosquito-ridden bog for a while, trying to record a frog making noises. So, I do have the patience when necessary, and a lot of mosquito scars to prove it. But yeah, it's wonderful. And today, you're saying today or this week is ESA Day, where you open the place up.
We have an open days this weekend.
And is this can anyone book this? Basically, is it?
Yes, anyone can book this. However, I think being so short in advance of the open day, I think it's already fully booked. But I don't have an overview of that.
But like for next year or for future years, people should consider getting there and checking
Keep an eye out. First weekend of October, it's the open day at ESTEC, and really you're then at the technological heart of ESA. Our headquarters is in Paris. We have establishments in the UK, in Italy, Spain, Germany. The technical heart is in the Netherlands. We have the test facilities. You will see facilities which actually can simulate launch vibrations of satellites. I mean, it's huge. They can do. Wow. We have an acoustic chamber when they can have a complete payload bay of a rocket. Where I would strongly advise you not to be in the acoustic chamber when it's working, because you will survive only a few seconds.
Really?
Because the acoustic loads on during a launch, the noise and the impact that has on the structure is huge. Oh, wow. It's underestimated and not understood, I think, by a lot of people. But it's not only the acceleration of a rocket, but it's also the noise which is generated and the noise waves. It's like going to a concert and you feel the bass player in your stomach. That's what happens to a rocket.
Oh my gosh, yeah, that's true. I mean, just thinking about, we just went to a Weezer concert and I was amazed at how I could feel everything in the. I was like, am I getting old? Things seem to be moving that I don't remember moving before. That's wow. Okay, so definitely gonna suggest that if people get the chance to do this, I think what we should do is we should set up like an ESA tour where do it as like a holiday where you just go from each different part of Europe that houses some kind of ESA thing, and eat lots of cheese.
Make sure you include ESTEC, because that's really where a lot of the I would say the projects are materializing. Usually when a satellite is built in the European industry, then like the Galileo satellites for the Europe, I always call it the European GPS. The Galileo satellites, they're tested at ESTEC. So once they're built, they come to ESTEC and we do the environmental testing there. So
did you have Juice
test them under vacuum.
Was Juice there as well?
Sorry?
Juice, the Jupiter, that one as well. Wow. That's my new. That's one of my new favorite things to obsess about now too. Even just how they get there is extraordinary. Even just the whole concept of I always, the slingshot thing. I was like, you use the thing and you use the gravity and fly yourself off into space. I didn't realize you use it for braking as well. It's so genius.
That whole orbit calculations. It's an art in itself. How people do that.
It is it's a dark art of magical. I can't get my head around it. Although I can't get that. I can't look. I want to see the installation manual for your 3D printer.
I will just show you, because I didn't find the initial file, but I'm going to present about the 3D printer at the end of October on the International Aeronautics Conference in Milan.
Oh, cool.
And so I give you a sneak preview.
Ooh, here we go. Early access,
of
folks. Oh,
wow. So here you can see this is not what we have printed in space, but this is actually the part which we're printing now in space. But this is the the installation of the 3D printer by Andreas Mogensen, and this is an image where I don't know why they included that, because they're really very rough with the.
I was gonna say, you've got to be going like, what are you doing? Yeah.
They try to get the lid off, but also here you see that there are different angles because there's no gravity. So this is a 180 kilos beast, and they're handling it like a bodybuilder. I mean,
Oh
and
my God, I forgot about that. That's true. That takes the back-breaking work out of it.
Yeah.
But
So here you see that it's installed in the experiment cabinet. So here it's installed. There is a frame which basically mounts it into the rack.
right.
And then the different like power, data,
Yeah.
the cooling, the nitrogen, that's all connected to the
my
cabinet.
God.
And then we start.
That's like a
And,
cable management nightmare.
and this is the one which is printed in space.
Wow. So that's literally you doing it layer by layer.
Yeah, layer by layer, but this is accelerated. This is in the end, and
Yeah.
I will let you know when it happens, because at some point you will see that there is. So you see it, the flashing
Yeah.
on the.
That's the heat.
That's what I was talking about, the heat. Yeah,
Interesting. And it didn't show up until it got further in and further away from the base,
exactly.
of course.
Yeah,
Oh, and even worse now. Look at that.
yeah.
And are you seeing an effect on the material in that? Surely there must be something.
Good question.
You can't tell from the cameras.
Yeah. We can see a little bit from the cameras, but basically we want to investigate it once it's back. And as it looks now, the sample, this printed sample, so the one which you see here, held by one of the crew members, probably is going to be returned to Earth in November this year, so next month. Wow. And then it's going to ESA, and then we start the investigations. And at that moment, we are also much better positioned to answer questions like, I mean, does this heating affect the quality of the material printing?
That's a great excuse to have you back then. After once you've once you've done all the fancy chats, you can come back.
Yeah, now the lab work is starting.
Yeah. So will you get to? I mean, I know this is a silly, naive question, but will you get to hold it? Like, will you get to go like, hey, like that's?
I will get a selfie with it, for sure. Yeah, 100% sure.
But I mean, is there fear of contamination and stuff? You'd have to use gloves anyways? But I mean, is it something that you can that would be out in the air like that? Is it? Does it have to be protected? I just curious.
We've given that a bit of thought. We do not expect that it will make a lot of difference, because also the ones we printed on Earth are handled in open air in the lab, of course in lab conditions, so controlled temperature, controlled humidity, etc.
Right.
But with using the gloves, we actually prevent the contamination by hand.
Just the oil, and so we're just we're toxic.
Yeah. No, so I will have to wear the gloves, but yes,
I gotta see the selfie. Yeah, that's gotta be, that's like your World
I will not leave before.
Yeah, that's like a soccer trophy thing. You want to get it like,
and I think there will also be a bit of celebration when we get it in the lab here.
Yeah, no kidding.
This is for a lot of people. I mean, it's a large team. It's different organizations working, and within these different organizations, there are different people working, and everyone together. We have people on the engineering side, the operations side, the crew training. So everything has to work together to make sure that this is getting this result. So we also will make sure that as soon as
there's a lot of selfies.
There will be a lot of selfies.
Let me ask you one final question, if you don't mind. Just if someone is, like, let's say in high school right now or whatever, and they're thinking like, oh my God, this is amazing. Are there any advice, anything, are there specific things that you did that you think helped you get where you were, state of mind or study habits or even just what you focused on? Anything in particular?
I think the advantage of working in this in the space domain is that we do employ a lot of different disciplines. I mean, we also have legal departments, we have policy departments. So we have operational colleagues who are working on console to direct the astronauts and support the astronauts in their daily operations. Of course, a large part is engineering. So, of course, I mean, as I would always advise I mean, first of all, you really need to want it and to have the drive to do it. I think that's what I experienced myself, and from that drive, I started to go to university and study aerospace engineering.
Right. Where did you study? Where did you go?
In Delft, in the Technical University of Delft, which is it's quite renowned aerospace engineering. But quite honestly, the reason why I joined ESA 15 years ago was not because of the engineering skills, but because I was working on how do you employ satellite data. So data from Earth observation satellites, from telecom satellites, from GPS, how do we benefit from that on Earth? And how do we develop services based on that? That was the reason why I started here.
Wow.
But then there was a vacancy for working on the space station, and that was kind of, for me, how should I say?
Those are such completely different, I mean...
It is. But ESA is they're doing Earth observation, they're building rockets, they're building satellites, they're building satellite navigation, science satellites. So we cover the whole spectrum of space, including how do we benefit from it on Earth.
And of course, every single aspect of that requires communication, because there's no cables. It's all about how do you get that data back and forth.
Exactly. And maybe to add to David to what you have to like if you want to work in this is you working, and for me it goes without saying because it's like natural, and I think you will agree with that, and Agne will also agree with it. It's international, it's multidisciplinary. I mean, along the way you get to know a lot of people, visit a lot of places, and really opens a world.
Yeah.
And at the same time, the space world. I mean, I'm going to IAC. I already know I will meet a friend of mine there I haven't seen for 30 years.
Ha.
So it is, that's also one of the aspects. It's the network which keeps the drive alive.
Right. And it sounds like it just sounds like you are interested in all aspects of this. I mean, like it doesn't, there's nothing that doesn't sound fascinating from you. Like even the biology stuff, I mean, that's.
The underlying science is sometimes the most fascinating.
So maybe curiosity is the key.
Curiosity. Yeah.
That's fantastic. Look, Rob, thank you so much. Everyone in the chat, thank you for your fantastic questions. I'm sorry we didn't get to all of them, but I feel like we've covered, I think we've got everything. Is there anything, Agnes, is there anything that you think we should be covering? I'm also going to say a huge thank you to Agnes as well, who is a shadow agent working in the background. She didn't want to be on camera, but she has been absolutely instrumental in making this happen, and has even talking about setting me up with some more people to talk to. I can't imagine them being as interesting as you, Rob, but I'm sure they'll try.
Oh, there are definitely.
You know some of these people too, right? Is that,
Yeah, exactly.
All good and a heart. There you go. I think we're in good with Agnes as well. Rob, again, thank you so much. Everyone, thank you so much. This is like, I'm with Genius. This is what I pretend to be smart on television, and then I get to actually talk to people who know what the hell they're talking about and are making a huge change. And I thank you so much, Rob, for your enthusiasm. All of this. It's just absolutely wonderful.
It's been a pleasure, and also thanks for those watching, and I would say the very good questions. And it's been a pleasure to share this with you. And I think if you're asking what's fun about this job, this is part of it.
This is part of it. Yeah, there you go.
This is part of it.
That's where our jobs actually meet. So,
Exactly.
to me, this is the fun. This is what I love about the fact that by pretending to be in space, I get to talk to people who are actually working out there. That's amazing. All right, so I will wrap it up. I will let you go. You've been more than generous enough with your time. Thank you so much. And yes, until we geek again, I will say be brave, be kind,